Hello, me again. Okay, special right triangles. So we're going to be doing the unit circle, and ironically, the circle is created by a whole bunch of triangles. You should have seen these in geometry. You would have seen them in Algebra 2. They tend to be something that people remember, but not very fondly. But don't make them harder than they are. They're special triangles because you have to give exact answers, meaning that you need to use radicals rather than decimals, which we've already been doing because that's what they do in calc, and we're in pre-calc. So when you see a 30, 60, 90 triangle, which is creatively named 30, 60, 90 because there's a 30, 60, and 90 degree angle, it always has the same relationship between all the sides. So the short side, which is across from the 30, is some number, which I'm going to creatively call n. Then the hypotenuse is always twice as big as that. So that's 2n. So that's easy to go back and forth between, because if I know 1, I can either multiply it by 2, or I can divide by 2 to go back and forth between these. The other leg, the long leg, the one across from 60, is that same number but times the square root of 3. So that's where that one gets a little messy, is, as we've learned, dealing with radicals is not always that awesome. So the relationship between the sides always in the other special triangle, which is called, you guessed it, a 45-45 triangle, then in that case, it's like a square that got cut in half diagonally. So this side is actually the same as this side because it was a square. And then the hypotenuse is n, that same number that we have been using. Help. I'm kind of on the struggle bus here. There we go, times the square root of 2. Still messy, geez Louise. So why does that matter? Well, you're gonna have to use that information and remember those relationships in order to find ultimately sines, cosines, and tangents. But for today, we're just gonna be finding unknown sides. We can't use Pythagorean theorem like we have been because, like, if you look down at the first example, we only know one side. And you can't use Pythagorean theorem if you only know one thing. So what you're going to do when you are trying to find missing sides in either of these deals is I would suggest, go around and label the sides. And by that I mean, if it's a 30, 60, 90, label them n, 2n, and n root 3. Or if it's a 45, 45, do n, root 2. Putting them in the right spot, obviously. All right, after you do that, one of the sides is going to have a number given. And so you're going to use whatever that given side is to solve for n. Okay. And once you know n, obviously all of the sides in the triangle can be found using that n. So that's what we're going to do, is you're going to find the missing sides. And you're going to find the missing sides using the n that you just solved for. So like always, the notes only sort of start to make sense once you have a chance to try it all. So this one has a 60 labeled in my first example. That means, well, obviously this is a 90. And since they have to add up to 180, this has to be a 30, and I have my first special triangle. So I'm going to label, I'm going to do what the notes say because that's usually helpful. And I'm supposed to label it. I'll be using these labels because it's that kind of triangle. So across from the 30, which is the shortest leg, which is in my case this side, I'm going to write an n. The hypotenuse is 2n, which is always across from the 90. And then the long leg, according to my notes up above, is n times the square root of 3. So I'm just going down the list. I label my sides. Now I need to use the given side, which is down here, to solve for n. Okay, well that wasn't really hard because that side is n equals 2. So pretty much done solving for n. Sometimes it is that easy and sometimes it's not. So now I'm going to find the missing sides using n. All right, I literally just travel around the circle and go, okay, well if my n is 2, then up here 2 times that n value will be 4. So the y side is 4. This side over here on the left is supposed to take the number that I got for n times the square root of 3. Well, the number that I got for n is a 2. So I'm going to put that in front of my square root of 3. Now there's nothing I can really do because innies and outies don't mix. So side w has the length 2 root 3. Because in a 30-60 special triangle, they always have those relationships. And so once I know that short side n, I can just double it to get my hypotenuse and multiply it by root 3 to get my longer leg. Let's try a sort of easy, straightforward one for 45, 45. This is 90. This one obviously is 45 labeled. That means this has to be a 45, so they all add up to 90, excuse me, up to 180. So using what I have drawn up above, the 2 legs, meaning the ones that make the 90, those are going to be n, and then the hypotenuse is n root 2. So I labeled the sides using these values because it was a 45, 45. So now I'm going to use my given side. Where's there a given side? Right here. They gave me the 4. All right, so I still don't have to solve for n really because I can just look at it and know that the n is 4. Well, the side down here is pretty easy because if n is 4, then n is still 4. So side w is 4. Then I go to my other unknown side, and it says to take whatever you got for n, which was a 4, and multiply it by root 2. But innies and outies don't mix, so since the 4 is on the outside of the radical and the 2 is on the inside, that's all I can do. So side y would have a length of 4 root 2. Because that's the relationship. All of them have that same ratio as you can see up above. So we just keep using it. All right, so now the next ones are going to be a little bit more challenging. But I do it the same way. Across, this is a 30, 60, 90, I can see from the label. Across from the 30 would be my n. My hypotenuse would be double that. And my long leg would be n root 3. So I labeled the sides. Now here it's going to get a little trickier because if you go to the side where they told you some information, you end up with n root 3 equals 10. So I'm supposed to solve for n, so that will require me to divide that root 3, but I can't leave it with the root 3 in the bottom, so now I have to rationalize. So solving for n, I end up with 10 root 3 over regular 3. Okay, that's kind of deserving of a sad face because that's not the easiest number to work with. Well, I already know the side is 10 because it was given. This is what I just got for n, which means that's down here. So this has a 10 root 3 over 3 value, and that is the one they labeled as w. Now that I know n, I can go here and solve for y, because y is going to be 2 times what I just got for n. So keeping in mind that 2 is a 2 over 1, I get y equals 20, because 2 times 10. Root 3 stays protected because it's under the radical, over 3, which actually makes sense because that length is supposed to be double this one, and 20 root 3 over 3 is double my 10 root 3 over 3. So the numbers are not always nice and easy, and whole numbers, you sometimes kind of got to work for it. So good thing you're smart. Let's take a look at this last example, and then you can practice on your own, which I know you're very excited about. It's a 45-45. That means the two legs that make up the 90 are the samesies, and the hypotenuse will be that number times the square root of 2. All right, check that off my list. Now I'm supposed to go to the side that gave me some info, so that's this guy, and use it to solve for n. Boo. Because I need to solve for n, and I currently have n root 2 equals 7. So I need the n alone. So I need to divide the root 2. That seems easy enough until now, because now I have to rationalize it. So finally I find out that n will have a value of 7 root 2 over regular 2. But that's actually pretty good news, because that means this side has that value because it's an n, and this side has that same value because it's an n. So in this case, because it's a 45-45, my w and my y side that they labeled are identical, because that's how the 45-45 triangle works, is the two legs are identical. So hopefully that helps you if you were struggling to keep up in class or if you were gone. Have a great day, you guys.